that better than you guys do. We made a new NLP Quals course. So this will be the first time it's taught as a Quals course, but I did teach it a year ago as an advanced course. So the content's going to change a little bit, but we've gone through a lot of the material before and we have a lot to go. So, I guess at this point you're probably just like exhausted of hearing about course after course after course. And so I've got like a slide at the end on like course particulars and stuff, but what I actually really want to do is just convince you that NLP is cool. And then maybe you just take the course for that reason, or you'll take some other course that fits your schedule better, and that's fine too. So, here's kind of one way of thinking about NLP, how to define it. You can look at the little slide. Actually, I don't really have dogs, so I don't really find this that funny. But, what we want to do is build something that can actually respond to the language and not just, pick out a few random words, but actually do some real analysis and, really understand deeply the broad different types of language, right? And now the one cool thing about NLP is we have lots and lots of applications, right? So, you use NLP every day all the time, right? So in your spell checker, in your Google search. Some of you maybe use speech recognition. Is anybody using speech recognition? Is it Siri? Or other stuff? Oh yeah. So one thing I should say actually is that if you take my course, I'm going to beg you to speak up. Okay, I'm going to beg you to talk. So when I ask questions, I really appreciate answers. So there's a little bit, I want to give you a little bit of history of the field on 2 slides, and then give you like 4 or 5 slides of cool things that you'll know how to be able to build by the time the course is over. And we'll talk about why they're cool and who's building them already. So there's this interesting thing that happened in the field of NLP around the 90s. And basically what happened is we completely threw out everything that had been done before and started from scratch. Okay? And what had done before was roughly in the model of trying to build linguistic models in computation. Right? And so it's sort of typical of this kind of approach would be to look at something like these 2 sentences: colorless green ideas sleep furiously, sleep green ideas, I can't even read that, ideas green colorless. And then you've got this quote from a pretty famous linguist here that's basically saying like, oh, you could never use statistics to tell these things apart. There has to be some deeper analysis going on here. And that used to be what everybody focused on. So we were doing really deep models, trying to do really full semantics. But then we were doing somewhat toy domains, and we didn't actually have anything that would really work, and you couldn't even really build a spell checker with this stuff. And so then what happened was there was a big revolution in the 90s. Computers got faster. We were able to gather data. People started looking at what statisticians and machine learning people were doing. And one of the first big successes here was in speech recognition. And so this guy, Fred Jelinek, ran a group at IBM that built one of the first successful speech recognizers. And one of his most famous quotes is, "Whenever I fire a linguist, our recognition rate goes up." So there's a real shift in the field here, right? We said, okay, we don't really care about getting everything perfect. What we're going to do is just be really empirical. We're going to even know that the linguistics is wrong sometimes, but we're going to build stuff that actually works. And we're going to crank away on that. Right? So then that gets you a certain amount, but then, at least people like me, this is still controversial, but I personally believe that you need both. Right? And there's been a lot of efforts, a lot of my research, a lot of other efforts in the last 10 years to kind of bring it back together, to bring in the richer linguistics, but to still be really empirical and really statistical, and try to really care about how well things work in practice. Okay? And so in the 2010s, after you take this class, you can solve this problem. So you can go and start doing the research and tell us which way is actually the right way to go. Okay? So now, what kinds of things would we be able to do after the class? So these are just some classic problems, and these are the kinds of things we'll do. So you could look at an information extraction system where the goal is to take a bunch of text and automatically read that text and then fill a database with facts that came from the text. Right? And we can do this pretty well right now, 80–90% accuracies. This is our real statistical focus. Has anybody heard recently in the news there's been some examples of something like this? Watson. So Watson does do stuff like this, although it actually does a lot more, right? It plays a game and everything. It actually builds on top of systems that do this. But there's a really famous example of specifically an information extraction system at a huge scale recently. Has anybody heard of it? So it's called the Google Knowledge Graph. So have you noticed that when you're searching on Google now, sometimes say you search for a specific person, this little box will pop up over on the side, and it will have all these facts about that person? So what's going on there is somebody built a whole ton of information extraction algorithms, and they ran those information extraction algorithms against absolutely everything on the web. They took all those facts that they extracted and they organized them into this huge graph that tells you all about everything and how they're related, right? And now it's become a core part of search to use this knowledge graph, at least for Google. And you can even do really cool things like say, what's Tom Cruise's Kevin Bacon number? And it will search the graph and come back and say 3, right? And things like that, right? So I think that's cool. It's unclear, how important that is for life, but it's pretty cool that we're actually automatically extracting these things and using them. Okay, and then one of the holy grails in NLP, right? So question answering, natural language interaction. So rather than just doing search, you'd like to ask a very complicated query. You'd like to have the computer automatically analyze that query at a deep level and either give you a factual answer or maybe go and do something for you, like make your reservation at the restaurant tonight. This is an area that I do a lot of research in, something we'll talk about a lot during the class. So famous examples of this recently. So Siri, Wolfram Alpha. Have people heard of Wolfram Alpha? Yeah, some people probably use it. I use it sort of like as a glorified interface to Mathematica, but it does actually do some NLP in there. And then of course Siri. What's so cool about Siri?
It works.
It works at all?
Voice. It's voice.
It's voice. Yeah, so the voice recognition is really, really good there.
Yeah.
Now the NLP processing, how do people find that? Who's used it? It's a little bit more mixed, but one cool thing that it does is actually have a personality. So they actually have thought about the HCI, the interactive aspects. Now you can say whether this is a personality or not, but they're at least trying, and they're trying to make it sort of fun and interactive. And this is a place where sort of NLP meets HCI or something a little bit different than you might normally think about. Summarization. So one really, really cool application is to read a whole bunch of text and then write a shorter text that has all the same information, right? So people do this all the time. I'm sure some of you have read Cliff Notes in your life, right? So if we could do that automatically, that would be quite nice. CNN has these story highlights that appear up in the corner. I don't know if you've ever seen this. They'll sort of show you like the 5 key sentences or something that will extract everything for you. Now this is an interesting area because it's an area where I would claim it's just about to take off. So for everything else, I've got this little after slide showing you the really cool thing. And I would say keep your eyes open. Like there are companies that are doing this and aggregating news, and it's going to be a big deal over the next few years. And these algorithms are really getting quite good. And then of course machine translation, right? You can't talk about NLP without recognizing all the really cool stuff that's been going on in machine translation. So how many people use online translators, automated translators? Yeah, so that's kind of what I would expect, right? They're getting so good that they're actually useful, and you can almost have like text messaging conversations without it going completely crazy in the process and so forth. And we will talk about machine translation, and you will be able to understand, even with just a few weeks of lectures, sort of one algorithm behind the best state-of-the-art algorithm that Google and everybody's using to automatically learn these translation systems. And one cool thing about translation is that it's all learned, it's all automated, and that means that it will do well in some languages. So for example, here if you're translating French to English, you can really do quite well. It is impossible for journalists to enter Tibetan areas, so forth and so on. Any guesses on what kind of language pairs would be harder? Asian languages?
Languages with low data.
With low data? That's right.
Too much for Latin.
Latin? Right, so languages in the same language family tend to be easier, right? So French and English are relatively related. Romance languages are easy to go between each other. But for example, Japanese to English is much harder. This is a couple years old. The systems are probably better by now. But the exchange of financial stocks fell slightly prominent lower. I didn't get the idea, but I wouldn't call that a fluent sentence. Okay, and then in general, there's some sort of grand language comprehension things. So you'd like to be able to solve the SAT, or be able to answer arbitrary comprehension questions. And this is where now I'll finally bring in Watson, right? Because although this is not an unconstrained setting, there are a lot of different things that they were able to actually understand about these relatively obscure prompts, and then they were able to actually comprehend the language and do well and beat these really amazing humans that are so much better than I am. Okay? So that's kind of a rough feel for the kind of stuff that we'll be able to understand. And all the algorithms behind all those things, we will cover at least some version of them, to the point where you could easily go and read the literature to figure out what's going on in practice. So the work is really interdisciplinary, and we draw on all these different areas, but we won't actually cover much of them. We'll just touch here and there where appropriate. And then, of course, all the boring stuff. So we've got these books, certain prerequisites, a certain amount of work and grading and so forth. Check in again when the class comes closer. This is all still a little bit in flux since this is the first time we're teaching it. But roughly, you need to have heard of dynamic programming, probability and statistics and things like this. Because we'll do a lot of linguistics, in general, there'll be some stuff that you won't know, and that's fine, and we'll help you figure it out. So we won't expect all the students coming in to have the perfect background in all the areas, but if you've never heard of any of these words, it'll be harder for you. Okay? And, really when you think about NLP and you think about how it's done in modern practice, we really are thinking about the intersections of the linguistics, the statistical and empirical issues, and the engineering issues. So when I say we want these information extraction systems to run on everything on the web, we really mean that. We really want them to run at scale. We really want them to process everything, and that comes with a whole other set of challenges. So, that's just sort of for summary. Here's basically another slide saying what I've already said. But we're going to require a certain amount of maturity, we're going to have a lot of fun, and then by the end you're going to know how to build these really useful tools, read the literature, and really understand what's going on with all these cool applications. So I'm happy to take any questions before my time. Yeah?
When is this being offered?
Oh, sorry, yeah, it's in the winter. It's on the first slide. Anything else? Okay, thanks.